Alright, let's start with facing. Sorry, the last video ran out of time. Only have 15 minutes, and that's not at all what I wanted to do. I deleted the wrong thing. Okay, so let's start with facing nonetheless. I'll just start completely over. I'll show you how quick this can actually go. So if we right click here, facing is just a simple 2D operation, so mill 2 axis, machining strategy, facing. Gotta go through. I want to use a 50 millimeter face mill. You can do math functions in these boxes. I'll just accept those speeds and feeds inputs. And again, if I want to change tool number here, I can do that. I just click, uncheck this automatic tool numbering, put tool 2 there. Actually, tool 1 because we're starting all over anyway, and go with that. And we want to zig, meaning one direction. I want to start in the upper left hand corner, so it starts here and goes this way. 50% of tool diameter step over is fine with me. And we'll just, again, I'm kind of glossing over because we don't really do much with leads here. It'll start 1 inch off the workpiece and work its way in, or whatever distance you give here. Leads, don't really need one in this case because it's already set up in the last tab. Links, how's it going to go from one to the next? I'm just going to go direct. I'm not going to arc to, and this is somewhat arbitrary, not arbitrary, but you just don't mess with it very often. Advanced feed rates, no reason to do that. We might do that if we were doing some chip thinning strategy, but we're not. So then we will just finish this. You see it populate here. I'll right click, select this face, say OK to that, and then compute. Compute. There we go. Now you notice I didn't change my depth. 2D toolpaths are dumb. They do what you tell them to do, or they're only as smart as their operator anyway. So in this case, I want to change my depth. So I just right click and I edit that, and I'll say I want to be 0 depth. We'll see if this computes. Sure does. It goes 0. Now, in this case, what I probably did was I came down, touched the 50 millimeter tool to the top of the part, zeroed, moved down 10 thousandths. Then we face everything off. And honestly, we can use this 50 millimeter tool to rough out around the part as well. This will give us an opportunity to show you how rust roughing works. So we'll accept this, save it. If I wanted some other 2D geometry to be facing for whatever reason, that will be covered later. But for the most part, in a part like this, we can just select that top face and let it go to work. Okay, from here, I want to do a mill 3 axis. And I want to do another Z-level rough. So from here, I'll just pick that Z-level rough strategy, go to next, and this tool is actually okay. 50 millimeter tool, actually, if you're doing a high feed milling, again, shallow depth passes, but large step overs, that 50 millimeter tool, or any of those inserted tools actually work really well for that application. And since I want to remove all of that perimeter material so I can cube it, the wider the tool, the less time it's going to take to do it. So from here, we'll accept the speeds and feeds based on the material we chose earlier. We're going to pocket in from the outside and depth of cut. We're going to go 32 thou depth of cut, and step over can probably be a little larger, but I'm going to stick with this just to get this populating, moving. So we'll finish that. Then we'll select our geometry. It's always best to select the entire thing. And we'll just go ahead and compute. So because of the size of the tool and where my stock is at, with that big a tool, right, it's only looking or thinking it can fit that tool within that stock, right? So if I want to use that tool, I want to use a 3D path, I have to lie to it and tell it that my stock's even bigger than that. Or I have to use some sort of 2D method that isn't stock aware. So just come here and make my X 10, 10, which really, and we'll say okay. And now you can see it's going around the part in a high feed milling sort of application. No, that's been roughed out, but I didn't leave any material XYZ, so I'll leave 5. Actually, we'll leave 10 on all surfaces. I want to drive that past bottom of the part, so I know my part's half-inch thick, so I'll just say 0.525 to make sure it goes deep enough. Oh, I didn't put a negative value. I'll leave all my mistakes in here for you to see what happens when you do and what it looks like. So here we go. Again, there's probably more depth passes than we needed or step overs, but you get the idea. So now if I want to clean up around the perimeter, we can do this in a few different ways. We can use a 3-axis toolpath is probably the easiest, best. So we'll come here and I'll get a chance to show you some rest roughing, but I can also add under my feature, what is really like one geometry set is a feature, right? Under that, I can have multiple strategies. So right now I've got a Z-level rough, but if I want, I can always come back in here to machining strategy, and I'm going to do an advanced rough after that. And you'll see the utility of this quickly. Now this is kind of adaptable to just about any part to start out with. I want to use a 1/2-inch cutter. It's going to automatically make that. Hold on a minute. It didn't actually automatically make that tool one because I didn't have automatic tool numbers so selected. So I'll make that tool 2 myself. Take the speeds and feeds. Actually depth of cut here, we can say 0.5 because we know we're not taking much. And now advanced rough has a bunch of utilities to it. You can see all the different strategies here. For now, I'm just going to do offset in, and leads I'm going to leave very basic. I mean, all these things you can play with over time, but I'm just here to get you started. Machine flatlands. A flatland is anything. Let's check this, see what we get. Like this, for instance, would be a flatland. If I want the feature-based machining to be aware to do this, then I would check flatlands. You think by default it would be there, but it's not. We don't really have a flatland down this part, but it doesn't hurt to have it checked either. Actually, it might machine the top of the part, so we'll see what happens here. Now here's the thing I wanted to get to. It's going to look to see what remaining stock was left from our roughing cycle and then go ahead and finish that out. So if I compute this, it's going to compute both of these again. So I'm just going to finish this, and you'll see it show up down here and only compute the feature that I'm interested in. So you see there's my tool path, there's my lead on and off. It's smart enough to know my step overs, so it's cleaning this up for me based on the tool that was there previously. Let me blank this stuff. So the next basic thing is to come here and just right click, assuming that my correct machine is selected, I can always edit this post processor, and you'll see you have all these arrays, whether it's Miltronics or whatever. So let's pick Centurion 6, OK, and then right click and post. Once that's done, from here we right click, save as, then we just save it to our drive, right? Probably save it as an all file, save it to your drive, take it out to machine and run it. So a few basic things get you going. Right, Z-level rough, advanced rough are really extremely useful for just about any part. And just because I left 10 here doesn't mean I couldn't leave, 2 or 3 thousandths here. But also, when I right click and edit this quick, you can see I can break the advanced rough out between side and bottom allowance. And there's some other miniature curvature of how things are going to get attacked and stuff like that. But I'm really just trying to get the basics out, and then we can refine it later. So with a Z-level rough and advanced rough, you basically could have roughed this part and finished this part on the perimeter. Then after that, it's just about setting up, flipping it, holding it in the vise, and facing off the backside. Let me go ahead and do a simulation here, give you an idea. By the way, always save before you do a simulation. This is the time when it decides to crash. I'm just going to turn the toolpath off, give it a run. And that part is finished out. All right, if I want to see the workpiece, I can come in here, show it. You kind of get an idea of where the stock is at in relationship to the workpiece. If I look closely, I knew there was a chamfer there. I still have material there for that chamfer. So I'd really need to go back and chamfer that, but that is all the time I have in this video, so that'll come up in the next one.